My name's Ted Weatherford, and I'm VP of Business Development at Xsight Labs, and I've got my colleague, distinguished engineer here, Mr. John Carney.
Nice to be here.
And we'll take you through the company and its products and its real-world applications. Awesome. Thanks, John. So right off the bat, I just want you to know we're a fabless semiconductor company. We sell chips. We design, and we're fabless because we push them through TSMC. And we have two really relevant products for AI here. Two out of the big six that makes up an AI factory or a token machine. One's an Ethernet switch chip, and the other one is a DPU, or data processing unit. Sometimes they're called infrastructure processors. We'll tell you all about what that is. Great. So we're going to run real quick through the corporate vision stuff, let you know who we are, move right on to the products as soon as we can. We're founded in 2017, so we've been around a while. We call ourselves an early stage company, not a startup, because it's been 9 years. We're 200 people with another 45 contractors and 15 or so part-time folks. And we're located engineering-wise. 200 of us are engineers. Even us salesy types are engineers usually. So we're located in Israel in 3 locations there, Tel Aviv and Kiryat Gat, and then up north in Haifa. We also have a beautiful team of 30 or so people on the East Coast in both Boston and Research Triangle Park, Raleigh-Durham area. And then the business development and sales and marketing and application engineering is in San Jose, California. Where we are here today. And then we also have people overseas in Europe, Poland, Ukraine is where they came from originally. And then we have people in Scandinavia as well, and a couple folks in China. All right. We are a tier 1 VC funded company. Our chairman of the board is a serial entrepreneur. I think he's run 12 across the finish line in terms of change of controls, starting very famous companies like Marvell Semiconductors Galileo, which came the famous Prestera line and Ethernet, Silicon One Labia, the Xsight Labs that became the Nitro and the Graviton and the Trainium inside of Amazon. Wrote the first check to Yael Waldman for Mellanox that became a big part of NVIDIA's real success. So this is a real top tier group, Atreides, Fidelity, Battery, Microsoft's M12 investment group, AMD. It's a long list. I want to move right to the fact that we're at $440 million. It's really expensive to do these kind of chips. So having this kind of pedigree and having the money to go the distance is a big part of it. These are what we believe are the 6 highest average selling price, most complex products that are the pinnacles or the mainstay of an AI factory. It's, of course, the XPU or the GPU, the CPU, the DPU, which we'll introduce to you today and what it does, and also the performance NIC, or the NIC that you find a lot on the back end for performance. And then, of course, there's 2 switches now. There's the Ethernet we've all heard about forever, and then there's this new scale-up, which would be an example of like NVIDIA NVLink or this new Ultra Ethernet that Broadcom's introduced. And we do 2 of those. So it's exciting to have a 200-person engineering team, 40 to 60 overhead for everything else globally, going after these 2 products. They're 5-nanometer products, and they're all available now. So we're in general availability on both products, and we're in mass production on the first product, which is the X, which I'll cover. We are a software-defined infrastructure, software-defined networking, software-defined storage, software-defined everything is a buzzword. But we believe we really are, for the first time, the only chip company that came out with wire speed, energy efficient, actually programmable products that are running at the highest rates demanded by the cutting edge AI, okay? And not just AI, but any data center infrastructure. This is what I want to show you today and give you a comfort for, and it's really never happened before. There's always a performance hit or a price hit or a power hit. The reality is we have a lot of transistors in our I/O ring now. We're chip people, and you can do a lot now with those transistors that you're getting for whatever that bandwidth I/O ring. So when you're up at the high end and you're doing a lot of bandwidth in and out of your I/Os, you do have a sea of transistors. And we've said for AI in particular, but infrastructure in general, you can't know what the applications are going to be. You need a degree of agility that's profound. You also have to have the velocity of the software programmer, the software engineer, and especially with AI coding now. So we're really excited to have this ethos or this approach. So we're open. That means that our instruction sets are open, our collateral's open. We're trying to fight the good fight. We're trying to democratize everything in an era of verticalization. So we stand by that. We've already got people writing their own compilers on top of our Ethernet switch chip. So it's very exciting to be open because you get the crowdsourced, you get that momentum. We're programmable, as outlined a minute ago. We'll get into how deep we are programmable, but it's really a software engineer's perspective and dream with these products, not what we call chip heads or hardware folks like myself. It's really designed for Linux and open instruction sets to be able to code at a high level and still get to 800 gig, still get to high radix Ethernet switching. E-Series is the DPU. That's the one that's just flying off the shelves because nobody else has 800 gig yet. And so we took a approach philosophically of coming from a server, coming from an ARM server, not coming from a NIC, a network interface card or connectivity device. So we looked at it not from the hardwired, pipelined, fixed, rigid, efficient building block like the NIC. We looked at it from the compute side and worked the other direction. And this will come out in our whole ethos and in our architecture, which John will cover here soon. The X switch is the first product that's performing like a Tomahawk or a Marvell Teralynx or an NVIDIA Spectrum with less power, same latency, and full programmability from layer 1 to layer 4, all state full processing for forwarding with embedded memory switches. Never been done before. Okay, so these are the actual products and roadmap. So the E1 is our 800 gig product out now. We do different artificial derivatives. It's a monolithic die, so you can get the 24 core, okay, get different sizes. And then the E1L is a new tape out, but it's also in 5 nanometer, and it's the same interconnect to the ARM cores. It's the same ARM cores. It's the same caching subsystem. We have a P unit for the PCIe side. We have an E unit for the Ethernet side. Same. It's just we did a really small, super low power version. This allows us to go after control plane markets, sitting next to other routers and switches, or any control plane for any piece of gear in any market. But it also allows us to go after a full programmable, soft SDN, SDX approach to the smart NIC. So all of a sudden you can do 100 gig, 50 gig, 200 gig NIC at a ridiculously low power and price. The X series is the Ethernet switch, and the one now that we have out is a 12.8 terabit. And nobody has a 12.8 terabit monolithic die in 5 nanometers. So we have amazing high yields, which is price and cost, and very low power. We're getting to that later, but we're 180 watts to do a 12.8 T switch. And the nearest competitor is over 300, and some of them are 600. So it's devastatingly low power with the flexibility. X3 is just going to be a larger derivative of that. We're going to do a single tape out with a single die. That die might combine in different ways, and we will attack 3 different bandwidth and radix points with one tape out through that clever combining. But I can't tell you what the actual bandwidth is, but that's a next year product. And the E1L tapes out in a couple months. So we'll have that this year. E1 is in general availability, X2's in mass production.
Quick question.
Oh,
Have you already generated the 64 core ARM chip?
Yeah.
It's already done?
Yeah, it's done. We started with the top performing one and then did the down derivative.
Okay.
And then there's a
to get your sizing right.
Yeah, you come out with the high performance one and you take the price hit during the negotiation.
Then you turn off the other cores.
Yeah, you can turn off cores, you bin them.
Right.
There's a lot of clever ideas that we do to get the price where you and power where you need it. You have a lot of flexibility with all that stuff. You run the SerDes different speeds.
Mhm.
You can only have half the DRAM interfaces, half the cores, turn the core clocks down. You've got a lot of different latitude for tailing your power to your opportunity.